part 4 of Unit 1. It's a review of naming compounds and writing formulas. Okay. Compounds can be classified into two types, molecular and ionic. Molecular compounds are sometimes called covalent compounds because they have covalent bonds holding them together. Molecular compounds are formed when two nonmetals combine, and they're held together by covalent bonds, which are made of shared electrons. Ionic bonds form between a metal ion and a nonmetal ion, or a cation and an anion, and they're held together by the electrostatic forces caused by that electron donation. So the metal donates one or more electrons to the nonmetal. That leaves the metal atom as a cation, positive ion, and the nonmetal atom as an anion, a negative ion. The attraction between those opposite charges is what makes an ionic bond so strong. Binary molecular compounds are made of two nonmetals combined together. Some simple examples of binary molecular compounds are CO2, CO, H2O is an easy one. We've just got the two elements in each one, and we have multiple atoms of each element there. This table over here is the prefixes for if we were going to write the names of these elements. CO2 is one carbon and two oxygens, so you would think that it's monocarbon dioxide, but we never put mono on the first element that's listed if there's only one of them. So instead of being monocarbon dioxide, it's just carbon dioxide. CO, that's carbon monoxide because it's just one. H2O technically would be dihydrogen monoxide. So mono can go on the second one, just doesn't go on the first one. You need to have this list of prefixes memorized. So just a couple more examples here. If we wanted to write the formula for dinitrogen pentoxide, di means 2, pent means 5, so nitrogen oxide dinitrogen would be 2, and pent means 5, so N2O5 is dinitrogen pentoxide. For tetraphosphorus decachloride, tetra means 4, deca means 10. Looking at phosphorus and chloride, we just put a 4 here and a 10 here. So tetraphosphorus decachloride. As long as you have that list of prefixes memorized, binary molecular compounds are pretty easy. Binary ionic compounds involve one metal element, one non-metal element. To write the formula for those, we need to look at the charges of the two ions involved. So we'll start with a simple one. We want to look at the ionic compound sodium chloride. It forms between a sodium ion and a chloride ion. We know from our pattern on the periodic table that sodium forms an ion with a charge of +1, and chlorine forms the chloride ion with a charge of -1. To make those neutral, it only takes one atom of each to balance it out. So our formula is just Na1Cl1. We don't ever write the ones down there, so the formula for sodium chloride is just NaCl. Make sure you take the charges off of your final answer for the formulas for binary ionic compounds. If we wanted to look at the ion that forms between calcium and chloride, we know that the calcium ion has a charge of +2 and chloride is -1. So to make this neutral, we've got +2 and -1. We have to take 2 of these chloride ions to make the compound neutral. So we've got 2 separate -1 charges balancing out this +2 charge. An easy way to remember these subscripts, it's called the crisscross method. You take the charge of the first element and you make that number the subscript for the second element. You take the charge of the second element and make it the subscript for the first one. That becomes more handy when you're dealing with something like aluminum sulfide, which is an aluminum ion and a sulfur ion. Aluminum has a charge of +3, and sulfide has a charge of -2. Using that crisscross method, we're just going to take this 3 and put it down here as a subscript for sulfide, and this 2 goes here after aluminum. This makes our compound neutral because we've got 2 aluminum ions, each with a charge of +3, so it's got a total of +6. And we've got 3 sulfide ions, each with a charge of -2, for a total of -6. So +6 and -6 cancels out. So the important thing to remember is we're trying to make the charges neutral in ionic compounds. To write the name of these compounds when you're given the formula, it's pretty easy. You just have to name the ions that are involved. So we see a sodium ion and a chlorine. Remember that anions, the ending of those names are changed from the chlorine ion to the chloride. Fluorine becomes fluoride. Oxygen becomes oxide. So this first one is just sodium chloride. Second one, it's calcium chloride. In this last one, we have an aluminum ion and a sulfide ion, so it's aluminum. I'm going to abbreviate that one. Sulfide. So these subscripts, they don't show up in the name of ionic compounds like they did in molecular compounds. So if you see prefixes, that's your clue that it's a molecular compound, not an ionic one. Some transition metals have more than one possible charge, and we change the way those names are written to indicate what that charge is. Copper can have a charge of +1 or -1. So instead of just writing copper chloride twice, this actually becomes copper Roman numeral 1 chloride, which means we have a copper with a +1 charge, chloride with a -1, so we really just need one of each to make that one neutral. So CuCl is the formula for copper 1 chloride. Copper also has a possible charge of +2. We show that +2 with Roman numeral 2, copper 2 chloride. That's our clue that it's the copper +2 ion combining with the chloride ion. We would need to use the crisscross method and put that 2 down here, so CuCl2 is the formula for copper 2 chloride. So the transition metals that have more than one possible charge, you specify what that positive charge is by putting a Roman numeral in parentheses. You don't do that for every transition metal, just for those that have multiple charges. Zinc doesn't have multiple charges. It's always +2, so you would not write zinc 2 chloride, you would just write zinc chloride. You only use the Roman numeral when there are more than one possible charge. Polyatomic ions, hopefully you know that poly means many. Polyatomic ions are ions made from more than one atom. There's a whole list of these that you need to have memorized. Some common ones are the carbonate ion. So it's 3 oxygen atoms and 1 carbon that all together have a charge of -2. We've got the nitrite ion, NO2, with a -1 charge. All of these atoms together form this one ion with a -1 charge. Similar to nitrite, we have nitrate, NO3 minus. If you ever have a choice between similar polyatomic ions, one with fewer oxygens, one with more, fewer is going to have the suffix ITE, and the one with more oxygens is going to have the suffix ATE. But that's the basics of polyatomic ions. You need to have that list memorized. These function just like typical anions do in binary ionic compounds. Let's say we wanted to make a compound between sodium and the carbonate ion. Sodium has a charge of +1, carbonate has a charge of -2. To do our subscripts, we just take the 1. Over here we only need 1 carbonate to cancel out that charge. We're going to take this 2 and put it here. So we end up with Na2CO3. We get +2 from the 2 sodiums and -2 from the carbonate ion. It cancels out that way. If we wanted to make a more complex binary ionic compound, let's look at aluminum carbonate. Aluminum has a charge of +3. Carbonate has a charge of -2. To use our crisscross method, we're going to take this 2, put it down here after aluminum, and this 3 from aluminum, it's going to come down and jump on right here. Now we're not finished because it looks like we've got 2 aluminums, 1 carbon, and 33 oxygens. What we need to do with polyatomic ions and chemical formulas is put them in parentheses. This way we can see that we've got 3 distinct carbonate ions, not 1 carbon and 33 oxygens. Another example of that would be, let's look at calcium nitrate. Calcium has a +2 charge. Nitrate has a -1 charge. Put the 1 after calcium, the 2 after the nitrate. Yes, the charges are canceled out, but the formula is not right because it looks like 1 nitrogen and 32 oxygens. We have to put parentheses around the polyatomic ion nitrate to make that neutral. Let's talk about the basics of naming acids and bases. We'll start with bases, they're easier. A base is simply a cation joined with the hydroxide ion, OH-. That's a polyatomic ion that you need to have memorized. So some common bases are sodium hydroxide, potassium hydroxide, calcium hydroxide. We would need 2 hydroxides to balance out the +2 charge of calcium. There's no special rules for naming bases. You just name the 2 ions. Sodium hydroxide, potassium hydroxide, calcium hydroxide. We could have strontium hydroxide. Strontium's got a +2 charge, so we need 2 hydroxides to balance that out. So bases are easy. Acids, we've got a couple rules for writing the names of them. Acids start with a hydrogen ion, and then they're added to some anion. So a common acid, hydrochloric acid, is HCl. We look for the hydrogen that it starts with and the anion that it's bonded with. This is hydrochloric acid instead of hydrogen chloride. So our rule is when the ion ending is IDE, we're going to change the name. We're going to add a hydro onto the front, and then we're going to put an ic in the word acid on the end. So hydrogen chloride becomes hydrochloric acid. We could combine a hydrogen ion with a nitrite, NO2. +1, -1, this is still canceling out. Nitrite ends in an ITE. So the way we change hydrogen nitrite to make it an acid, we don't put a hydro on the front, we just have the name and we change the ending to an OUS, acid. So instead of being hydrogen nitrite, this is nitrous acid. We can make some more complicated acids. Let's look at the sulfate ion, SO4. SO4 has a charge of -2, so we need 2 hydrogens on the front to balance that out. Instead of being hydrogen sulfate, this is sulfuric acid. If you need to jot down these basic rules, these are the 3 different ways that we name acids: the hydro, ic, the OUS, and just the ic ending. Your question for this section: what is the formula of the compound formed between an iron +3 cation and the carbonate ion?